All right, so let's talk about something that's a little bit more complicated. Matrices. Now, what are matrices? If you've taken a lot of math in high school, you may have seen matrices before, but if you haven't taken as much, then, well, maybe you haven't really seen what a matrix is. Matrices, at their heart, really are just an array of numbers. It's a sequence of numbers written into rows and columns. Then we will put square brackets around those. For example, using sort of constants instead of values for now, we could look at a matrix with rows A, B, C, D, and E, F. Now this matrix, we write it in those brackets. Now we have 2 columns and 3 rows. This will actually determine what we call the dimensions of the matrix. When we're writing down the dimensions of a matrix, we always think about it as the number of rows by the number of columns. And we'll write it with an X, sort of as that by notation. So this one, having 3 rows and 2 columns, we would write it as a 3 by 2 matrix. Now that we have some idea of what a matrix is and how we can write it, well, how do we work with them? First, let's start off with the simple stuff. Addition, subtraction. Adding and subtracting matrices, as it turns out, really isn't that complicated. It may look a little weird to begin with, but with a couple of tries, it turns out to be pretty straightforward. All we really do is add corresponding entries. Now we have this 2 by 2 matrix with the first row of 1, 2, the second row 3, 4. And we're adding to that a second matrix that's a 2 by 2 with the first row 5, 6, and second row 7, 8. Now we add these, again, by just simply adding corresponding entries. The upper left entry of the first matrix plus the upper left entry of the second matrix will give us the upper left entry of the resulting matrix. That means the upper left entry of the result will be 1 plus 5, or 6. And then we just continue through the rest of the matrix. So for the upper right, it'll simply be upper right plus upper right. 2 plus 6 gives us 8. The lower left will get 3 plus 7, that'll give us 10, and the lower right will be 4 plus 8, which will give us 12. That will give us our resulting 2 by 2 matrix, 6, 8, 10, 12. Notice that the size of our result is the same as the size of the beginning matrices, and the 2 matrices we added had to be the same size. Again, we're adding corresponding entries. So the 2 matrices we're adding will always have to have the same dimensions. We can add a 2 by 2 to a 2 by 2, but I can't add a 2 by 2 to a 3 by 3. Likewise, I could add a 3 by 3 to a 3 by 3, but I couldn't add a 3 by 3 to a 3 by 4. That wouldn't work out. We have to have the right entries, the right number of rows, the right number of columns in order to be able to add them together. And again, the result will be the same size as whatever we started with. Now let's get a little bit more complicated. Matrix multiplication. Now again, if you've worked with matrices before, you may have seen this. Chances are you found it a little bit confusing, but that's okay. We can work through it. So let's take a look at an example. Now we have a product of these 2 matrices. The first is in fact a 2 by 3 matrix with first row 1, 2, 3, second row 4, 5, 6. The second is a 3 by 2 matrix with first row 1, 4, second row 2, 5, and third row 3, 6. Now the way we actually multiply these looks a little bit weird to start with. What we'll do is multiply a row of the first matrix times a column of the second matrix. So we think about getting the first row, first column of our result. Well, that we will take the first row of the first matrix and the first column of the second matrix. What we do is take those 2, that first row, that first column, we will multiply corresponding entries and then add those results together. Which means that upper left entry in our result will look like 1 times 1, 2 times 2, and 3 times 3, and we'll add those together. That will give us 1 plus 4 plus 9, or 14. And that's going to be the first row, first column in our resulting product. Then we'll continue. We'll take the second row times the first column. In that case, again, we'll multiply corresponding entries. Here we've got 4 times 1 plus 5 times 2 plus 6 times 3. So we add together 4, 10, and 18 and get 32. So again, the second row and first column will give us second row, first column. And we continue. We're halfway done. To get the second column, we'll take the first row of the first matrix and then the second column of the second matrix. We multiply corresponding entries and add them together. Looks a lot like the second row times the first column, because we happen to have, in this case, the same numbers multiplied together. We get 1 times 4 plus 2 times 5 plus 3 times 6. Again, that will give us 32. So the first row and second column of our result will be 32. Last but not least, second row, second column. We'll take 4, 5, 6 times 4, 5, 6, which means we get 4 times 4 plus 5 times 5 plus 6 times 6. That gives us 16 plus 25 plus 36, or a total of 77. And that goes in the second column, second row of our result. Now we've got it. We've got the resulting matrix 14, 32, 32, 77. Notice that the sizes are all different in this case. So when we can multiply, well, that's a little bit of a different issue. We have to have the same number of entries in each row of the first matrix as we have entries in the columns of the second matrix. Anytime that happens, we can multiply the two of them together and we'll end up with a resulting product. One last computation that they're going to ask you to make with matrices is what we call the determinant of a matrix. Now, what is the determinant? This is kind of a strange concept. You can kind of think about it like almost like absolute value for matrices. It's a way of sort of measuring a matrix. Remember, we talked about absolute value as sort of a distance from 0, or the size of a number. Well, for matrices, the way we measure that is by using the determinant. Now, as far as determinants go, you'll only ever need to find the determinant of a 2 by 2 matrix. In fact, we can only ever find determinants of square matrices, 2 by 2, 3 by 3, 4 by 4. But as sizes get bigger, they get almost exponentially more complicated. So you'll never have to do anything beyond a simple 2 by 2 matrix. And all we do is remember a formula. If we have this matrix, A, B, C, D, again, first row, A, B, second row, C, D. All we do is multiply across what we would call the major diagonal, and then multiply across what we'd call the minor diagonal, and subtract those. The major diagonal goes upper left and lower right. The minor diagonal goes upper right and lower left. So the formula becomes AD minus BC. Remember that formula? It's really not so bad. Let's take a look at an example. So we've got this 2 by 2 matrix. First row 4, 6, second row -2, 5. Again, finding that determinant, we just multiply across the major diagonal minus the product across the minor diagonal. That will give us 4 times 5 minus 6 times -2. 4 times 5 is 20, 6 times -2 is -12, so we end up getting 20 minus -12, or 20 plus 12, for a total of 32. And there we go, not so bad.